Okay, good morning. Welcome to
Family Math number 60.
Family Math number 60. Sorry, I have a little cough this morning. Yesterday I was absolutely shocked to learn about a very simple problem in math that's unsolved, and I had never heard of it before. And the reason I'm so surprised is it's so simple. I can't believe I'd never seen this before. The problem, I mean, obviously it's unsolved, so that means it must be hard to solve, right?
Yes.
Okay, so it's called finding a perfect cuboid, or sometimes it's called the Euler brick. And so to understand this problem, we have to start with a simple rectangle. And the problem with a rectangle would be find a rectangle that has integer side lengths and also integer diagonals. Okay? And the one thing you've probably not heard of, or maybe you have, is it's called the Pythagorean Theorem.
I've heard of it a little bit.
And it says, the Pythagorean Theorem says, if this side is A, this side is B, and this side is C, and we have a right triangle, which is what you get when in a rectangle when you draw the diagonal. Do you see the triangle here?
Yeah, there's two.
Yeah? And do you know what a right angle means?
Well, it's like a perfect, like an angle in a square.
Right, exactly right. The Pythagorean Theorem says A squared plus B squared equals C squared. And so the Pythagorean Theorem would tell you for a rectangle, for example, if one side was 3, one side was 4, let's figure that out. What's 3 squared? We talked about that yesterday.
3 squared is 9.
9. What's 4 squared?
4 squared is 16.
What's 9 plus 16?
9 plus 16 is 25.
So this equals 25, and that's C squared. So what if C squared is 25? What is C?
C is 5.
C is 5. Okay? So the Pythagorean Theorem tells you that one possible solution to this would be 3, 4, 5. So you could have a rectangle with integer sides and an integer diagonal. Okay? Now, it's a little bit more complicated when you have a box. Okay, can we lift this box?
I think so.
On here?
It's kind of hard.
Kind of hard to lift?
They break easily.
Okay, well let's lift it in pieces. Okay, so for a birthday present, we got these, what are they called? Magnet tiles?
Magnet tiles.
Magnet tiles. Okay, a little bit harder when we have a box. And hopefully you can see the box. Now we're going to have a side length here, a side length here, and also a side length going up, right? So now I've got 3 diagonals. I've got the diagonal that goes across the bottom. That's the one we just had, right, with our rectangle? Okay, so that could work if it was 3, 4, 5. But now I also have this side of the box here, so I've got a diagonal here, and I've got a diagonal on this side of the box. Okay, so I've got 3 diagonals now. Do you see that?
Yeah.
And it turns out that somebody figured out that if this side is 80, well, let's see. Let's move this off. So I have a box like this. Maybe it's just easier to draw it. If this side is 85, this side is 725, and this side is 732, okay? Then they figured out that, oh, sorry, those are the lengths of the diagonals. If this side is 85, this side's 132, and this side is 720, they figured out that this diagonal is 732. The diagonal across the bottom of the box is 725. And the diagonal in this corner, the front face of the box, is 157. Okay, so somebody solved that problem. Okay?
I thought it was an unsolved problem.
Somebody solved that problem with the box. But there's one other diagonal. There's one more diagonal here. Are you ready?
Is it a 4D shape?
Let's bring our box back.
We have to rebuild it.
Yeah, let's rebuild it really quick, like a box building boxers. Okay, there's one more diagonal in this box, and it goes from this lower corner here to the upper corner here, so it goes across the middle of the box. Do you see that?
Yeah. Yeah.
And nobody's ever figured out, ever, if you can have 3 sides that are integers, have 3 diagonals on the faces, be integers, and then also have this middle diagonal be an integer. Isn't that cool?
Yeah.
Because all it is is arithmetic with small integers and the Pythagorean theorem. And yet nobody's ever solved this. If you solved it, you'd be
Famous.
famous. Pretty cool problem, right?
Yep.
I like that problem. I'm amazed. I'm totally amazed. So no one's ever solved. And all it is the Pythagorean theorem. Pretty cool. You guys like learning about that?
Yeah.
All right, good job.